Determine whether the inequality is satisfied by the given number. So what we have here is the inequality 1 minus 4x is greater than negative 1. And they're asking, is that satisfied, or is it true when we plug in a 9 for x? So when we plug in this number 9 for the x, is this statement going to be true? So let's plug it in and see. We're going to have 1 minus 4 times 9. Is that greater than negative 1? 1 minus 36 greater than negative 1. So you're going to have negative 35. Is that greater than negative 1? No, that's less than negative 1. So this is not true. Which means when we plug in a 9, this is not satisfied. It's not a true inequality. So no would be the answer there. For number 4, I have the equation wrong here. It's, let's see, negative 7 minus x is greater than or equal to negative 9. To solve this, you want to get x all by itself. First thing we want to do is get rid of this negative 7. And to do that, we'll add 7 to both sides. When you add 7 over here, the negative 7 and add 7 cancel out, so you just have the x. And when you add 7 over here, you'll have only negative 2. Negative 9 plus 7 is negative 2. Now we got to get rid of the negative on both sides. So multiply both sides by a negative 1. The negatives cancel out. So multiply here by a negative 1, multiply here by a negative 1. The numbers don't change because you're multiplying by 1, but the negative makes the negatives cancel out. And whenever you do an inequality and you multiply by a negative or you divide by a negative, you got to flip the sign around. So now our greater than became a less than. So we got x all by itself. We want x is less than or equal to 2. Looks like this is the correct graph, but less than or equal to means we need brackets like this, and the interval notation here has a parentheses instead of a bracket. And also we're going down to negative infinity, not positive infinity. So here's the correct interval notation. We're from negative infinity up to 2 with a bracket, but the graph's wrong. C is what we want. The graph is from everything less than 2 is colored in. 2 has a bracket on it because it's less than or equal to. And then the interval notation matches. From negative infinity up to 2, and 2 has a bracket. Determine whether the compound inequality is true. So it means we need to check both of these and see if they're both true. It means that the compound inequality is true. So is 5 less than or equal to 5? And this is true because this symbol means less than or equal to, and 5 is equal to 5. So this is a true statement. 5 is less than or equal to 5. And also, is negative 5 less than or equal to 0? And that is true as well. Negatives, I always like to think about money. If I had negative $5, that's less than having $0. I'd actually be in debt. So yes, that's less than 0. And since they're both true, that means the compound inequality is true. If either one would have been false, we would have selected no. But the compound, which means both of them together, is true because they're both correct. 5 is less than or equal to 5, and negative 5 is less than or equal to 0 are both correct. So yes, the compound inequality is true. Alright, so this one says graph this compound inequality. X is less than or equal to 7, and x is greater than or equal to 0. So we're looking for numbers that have to be less than 7 or equal to, and they have to be greater than 0. at the same time that have to be satisfying this, they have to be less than 7, and at the same time they have to be bigger than 0. So some of these numbers here are less than 7, in fact they all are, but once you get down here they're not bigger than 0 anymore. So it's not making this part true. For B, these numbers are less than 7 and they're bigger than 0, and that's where we stop. So B is the correct answer because all of these numbers colored in are less than 7 and at the same time they're bigger than 0. Both of these statements have to be true. Okay, this one says x is less than 16 or x is greater than 0. So just the or means as long as one of these statements is true, we've satisfied the compound inequality. So we want to color in all the numbers that are less than 16. So let's just look at A here. It'd be coloring everything down less than 16, on and on forever. Those should all be colored in. That because we want everything less than 16. But we also want to color in everything greater than 0. So we'd start at 0 and color in everything greater than 0. So in fact, every single number gets colored in. Pick any number you want in the whole world. 106. Is it less than 16? No, but it is bigger than 0. So any number you pick, you're going to find that it either makes this true or it makes this true. It makes this or that true, so it's an answer. So again, to differentiate with the and, both of them have to be true at the same exact time. So only numbers less than 7 and bigger than 0. But with the or, as long as it's making one or the other true, it's a number that works. So the problem with this answer is, it cuts off at 99. So 100, we're saying, this answer is saying that 100 doesn't work. But 100 is bigger than 0, so 100 should work. Any number bigger than 0 should be considered an answer.